polymer concrete? In normal concrete, the water dries up and leaves the pores. These pores become the entries of various liquids or gases. The presence of pores also reduces the strength in terms of flexural and compressive strength and make the concrete poor and resistant. Make the concrete also easily disrupted by sulfate and acid attack. Therefore, to overcome these problems, the polymer concrete are being developed and introduced. A polymer is a large molecule containing hundreds or thousands of atoms formed combining one, two or more kind of small molecules, which is called as monomers, into chain or network structure. What is a polymer concrete? Polymer concrete is a type of concrete either use polymer material as a supplement or replacement of the binder. The polymer binder, which may be a thermoplastic but more frequently is a thermosetting polymer, plus with mineral filler like aggregates, crushed stone and gravel. The addition of polymer in concrete results in a polymerization of monomer and aggregate mixture. The polymerized of a monomer acts as a binder for aggregate and resulting a composite concrete. The main technique in producing polymer concrete is to minimize the volume of voids between the aggregates. So let's take a look on the advantages of the polymer concrete. First advantages is the rapid curing at ambient temperature, good adhesion at most surface, high flexural and compressive strength, low permeability of water, good long-term durability, and good chemical resistance and corrosion. Fly ash is an inorganic waste material that can be obtained from the coal, which is environmental friendly and economical friendly.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ihsan. Today I will talk about basic concept of polymer concrete. Commonly used type of resin in polymer concrete is epoxy resin, furan resin, and acrylic. This type of resin will give different outcomes. Other than that, binder content, aggregate, segregation, curing condition, and etc. will affecting the polymer concrete. The properties of polymer concrete are dependent on the properties of aggregate, purity, cleanliness, and design mixture. Usually, properties divided into two parts, which is mechanical properties and chemical properties. As for mechanical properties, the compressive strength of polymer concrete is either similar or greater than Portland cement. Polymer concrete is durable due to very low permeable to water and absorptive solutions. As for chemical properties, it is high in thermal reaction, so it is durable in the condition of rapid freeze and thaw cycles. Polymer concrete also is resistant to chemicals. It can survive chemical reaction like that of sulfate, oil, acid, and alkali. It is also resistant to corrosion. Polymer concrete does not allow the intrusion of carbon dioxide, so there are several testing to perform in order to find the best outcome of the concrete ability. Number 1, the compression test is used to determine the hardened concrete strength and compression and to measure of the concrete resistant to compressive load. Number 2, an indication of concrete beam or slab strength known as flexural strength is determined by the material ability to bend under tension. For an unreinforced concrete slab or beam to withstand bending failure, why it can be used in the construction work and repairing work. Moreover, due to the low permeability and corrosion resistance, it can be used in repairing corrosion damaged concrete, swimming pools, water tanks.
Assalamualaikum, I am Nurul Zafira and today I am going to present about materials, design procedure and data analysis. Materials that we need for this procedure are epoxy resin, hardener, fly ash class F and also aggregate size of 0 to 4 mm and 4 to 8 mm. For the polymer concrete mixture, mix in the required quantities of binder between epoxy resin and also hardener, then mix the aggregate and added filler which is fly ash class F into the mechanical mixer, and the mixture was poured in a mold and the curing process started for 14 days. For the data analysis, we started with the composition of fly ash class F, and as we can see, it is high in silica and alumina but low in calcium. From the table, we can see that we have 10 samples with different percent of epoxy resin, fly ash and also aggregates. Next, this table shows the mechanical properties of the polymer concrete without fly ash in terms of compressive strength, flexural strength and also split strength. And the next table shows the mechanical properties of the polymer concrete with fly ash and sample with 12.4% of epoxy resin will be plotted on a graph, and this is the graph that been plotted with 12.4% of epoxy resin in terms of compressive strength, flexural strength and split strength versus fly ash.
Hello, my name is Ahmad Fitri Hakim and I'm going to talk about compressive strength, flexural strength and split strength of polymer concrete with 12.4 epoxy resin and with different dosage of fly ash. 3 samples have been tested, which sample 1 is 6.4, sample 2 is 7.2 and sample 3 is 12.8% of fly ash dosage. The first graph represents compressive strength versus fly ash for 12.4% of epoxy resin. The highest compressive strength for 12.4% epoxy resin was from sample 3, which is 69.82 MPa, and the lowest value of compressive strength is 57.69 MPa, which was from sample 1. From the result, it concludes that the higher the dosage of fly ash, the compressive strength of the concrete also will be higher. This is because the dosage of fly ash that has been put into the concrete, which is 12.8%, is higher than sample 1 and 2, which was 6.4% and 7.2% respectively. From flexural strength graph, the dosage of the fly ash affected the performance for flexural strength of the concrete, where we can see from the first sample with 6.4% of fly ash dosage, the flexural strength obtained is 16.67 MPa, which is the highest among 3 samples with the same 12.4% of epoxy resin. The value of flexural strength decreases as the dosage of the fly ash increases, where the value of flexural strength drops from sample 2, which is 15.86%, to sample 3, which is 14.3%. This is because the fly ash does not have a great effect on flexural strength compared to compression and split tensile. According to split strength graph, the split strength for 3 samples with 12.4% of epoxy resin increased, aligning with the increments of the fly ash dosage. For sample 1, with 6.4% of fly ash dosage, the split strength value obtained is 5.67 MPa, while for sample 2 with 7.2% of fly ash dosage, the value for split strength observed increased to 6.49%. The value continued to rise until 7.18% as the fly ash dosage for sample 3 increased with 12.8%. From the graph, it is observed that as the fly ash dosage increases, the split strength for the concrete with 12.4% of epoxy resin also increases.
So, as we can conclude from the data of the hydrogen test, the polymer concrete of 12.4% epoxy resin with fly ash is showing greater result than without the fly ash. The addition of percentage for the fly ash into the polymer concrete with 12.4% resin content improve the compression strength and split tensile strength of the concrete, but the flexural strength did not showing the great effect to the polymer concrete compared to the compression and also split tensile strength. The compression and split tensile strength for the concrete indicates that it gets more stronger parallel to the increment of the fly ash percentage. The epoxy resin incorporated in mortar composition also could bring an improvement in the properties of the mortar and the concrete. The strength and durability of polymer concrete can be used in highway surfaces repair since it's quick cooked and operated.